Hello, I'm Julie, and I'm one of the pre-calc instructors here, and I'm going to do a couple weird functions in this video for you. I got a little smudge there. Hopefully the board works today. We've been having issues, but I think we're good. All right, greatest integer function is kind of a weird one, and basically what it gives you is the biggest integer less than or equal to your input, or your x, okay? And I think the easiest way to think about this is less than or equal to, we're going to go to the left on a number line. So to understand this function, if you have, say, 3.2, think of a number line. And here's, 3 on the number line, there's 4. 3.2 is here about. So going to the integer that's less than or equal to it, that would give you 3, okay? If you have 4.9, so you graph it, again, that's your kind of go-to. You're like, oh, 4.9 is here. But again, remember, it's less than or equal to. You want the greatest integer that is less than or equal to 4.9. So you go to the left. That would be 4, okay? If you have a negative, so say you have a negative 3.8, okay? All right, so on my number line, here's my negative 3, here's my negative 4. Negative 3.8 is here. Again, less than or equal to would go to the left. That would be a negative 4, okay? So that's how the greatest integer function works. It's really a step function when you graph it, and the best example I would say in real life for that would be like maybe postage, possibly we're in Iowa, so maybe if you wrestle, all right, that might do it because there's weight classes. And so what I'm saying is on your graph, maybe if the package weighs between a little bit, obviously if it weighs 0, you pay 0, right? Okay. But say up to 5 pounds, say it weighs a little bit more than 5 pounds, right? Or 0, sorry, it's above 0. So 0.1, 0.2, whatever. And then say all the way up to 5 pounds, we charge, say, $10 to weigh, for those weights, to mail it, right? Okay. And then maybe up to 10 pounds. So as soon as you get above 5, again, open hole, maybe we're jumping up to $20 here to mail these. It's expensive. So let me get my hole a little higher there. So if it's 5 pounds, these are my pounds. If it's 5 pounds, you're still going to pay the $10. But as soon as you creep just a tad over 5.001, you're going to go up to the next pay scale and say that goes all the way up to 10 pounds, okay? And then again, kind of the same situation, a little bit above 10 pounds, and you keep going. That's a step function. That's what this guy's going to look like, okay? And I think, again, the way to get a feel for this is to make an input-output chart to kind of, again, give your brain a way to think about this. So I'm going to make X, Y. And here's my input, and here's my output, because remember, points are really data points. They're really input and output. Okay, so let's, obviously, 0 would go to 0, 1, 1, 2, 2, right? So we know, like, 0 would go to 0, 1 would go to 1, negative 3 would go to negative 3. Okay, but what about decimals, all right? So let's kind of get a feel for this. 1.8, so think on a number line. Here's 1, here's 2. 1.8 would go to 1. So would 1.9, okay? But if I'm at, say, 2.2, that's going to go to 2, because, again, between 2 and 3, 2.2 would go there. Think of negatives, right? Okay, so where would, let's come up here. Where would a negative 3.9 go? Well, here's negative 4, here's negative 3. Negative 3.9 would go to a negative 4. So we can kind of get a little bit of a feel for it. All right, so let's graph it. All right, so we will go, let's see, 1, 2, 3, 4, 5, and then up here, 1, 2, 3, 4. All right, so kind of running out of space there, but we'll get the gist of it. Okay, if I have 0, 0, so at 0, 0, I have 0.11, 2, 2. All those guys are going to land nicely where they belong, 4, 4, so forth. Okay. It's the decimals that we have to figure out where they're going. Okay, so if my input is 0.1, right, it would go to 0. If I have 0.9, it would go to the left to 0. So it's going to go to the left. But if it's 1, it's going to jump up here. So I need a whole, because even if it's 0.999, it's going to go to the left, okay? Kind of think of your input and output or how we started the video. All right, if it's 1, we're up here. Okay, 1.1 would go to the left to 1, and all of these would. Even, you know, if I'm at 1.999, it would go to the left, less than or equal to. It would go here. So once you get a feel for this, you're like, oh, they're all going to do that. And then same thing on the negative side. So let's look at negative. You're like, oh, it's going to behave the same pattern. And again, you can kind of think about that. If you're at -1, you're at -1. If you're at a -0.9, it would go to the left. If you're at a -0.5, it would go to the left. If you're at a -1/10, it would go to the left. And so this graph would continue infinite like this. Now, it is a function. Notice it passes a vertical line test, right? Like, you know, I'm passing the vertical line test. It is a step function, but it's the greatest integer function. All right, the other one I want to look at is going to be a piecewise function, which again is kind of a little different, but to be honest, in real life, probably more things are piecewise than anything else, okay? So I am gonna pause this for a second, and then I'm gonna pick up my video from then. All right, we're back with the piecewise function. Real life is kind of like this too sometimes, in a situation where you might get paid a certain amount for doing certain things, but then if you work overtime or you exceed what you're supposed to do for your job, you might get paid at a different rate for another thing, okay? And so we'll look at this. All right, so let's graph it, all right? I think the easiest thing to graph is probably this one to start out with. So I'm going to start there. So let me make my little tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have input and output. All right, this is not a number range. So if it was, it'd be a constant function, right? If it's like saying between, say, -2 and a +4, you're stuck at 2, it might be a constant. Okay, like a constant, like a line segment there. But that's not what this is saying. This is saying, hey, this is only 1 point. When the input is 1, your output is 2. All right, so when my input is 1, my output is 2. That's a single point. So check, we've got that guy done. All right, let's do this one. Again, I think we like positive numbers a little better, so let's do this. Now, this is a parabola, so you know it's gonna, you know the shape of a quadratic, but we're only looking at part of it. So again, if you want to make an input-output chart to kind of help you, because remember, points are really data points. They're input and output to the function. So I am going to put in numbers. Now, I'm going to put in 1, but I'm going to write a note to myself that that output is an open dot. It is an open point because it can't really land at 1. It's not equal to, it's just greater than. All right. But it could get like 1.00001 is greater than that. So I need to get super close to it. So I'm just going to put in 1, use the open dot to represent that it can't land there, but it can get infinite close to it. All right. So if I put 1 in, 1 squared is 1. So at 1, 1, I'm going to put an open dot. All right. Now, greater than is great. Now, I could put in decimals, but I know those points are going to work. So I'm just going to jump to 2. 2 squared is 4. 3 squared is 9. All right, so at 2, 1, 2, 3, 4. And then at, let's see, I might have to make this go up a little bit more. Where I'm at 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, I think so, hopefully. All right, and I know that's curvy, right? And that is connecting to that open dot. So I'm going to try to get that parabola shape. Again, I'm not the best drawer on a whiteboard, but it's not a line, right? This is like a part of a quadratic, so it's that part, right? And it should go directly through there and through there. Okay, so check, and it goes off to infinity, right? I mean, I could just put in 10 and get 100 there, right? That's going off to infinity. All right, so now I'm going to deal with this. All right, this tells me that this is a point. Okay, so, and it equals it, right? It's not a whole. So let's put in a -3. So again, I'm going to make an input-output chart up here. And first of all, I'm going to put in a -3, substitute a -3. -2 times -3 is 6 plus 1 is 7. So at a -3, I'm at 7. 1, 2, 3, 4, 5, 6, 7. That is a solid dot because it can land there. All right. Now, on the other end, let's go ahead. So I'm going to have points in the middle, so we could do that, I guess. If I put in a -2, I get 4 plus 1 is 5. So I had -2, 1, 2, 3, 4, 5. There's a point there. I could put in, zeros in that interval. So if I put in 0, substitute in 0, I get 1. So at 0, 1, I have another point. And again, these should be a straight line. It's just my tick marks are very good. All right, and then what else? Okay, at 1, that is the end, but notice this is a whole, right? It's a whole when it equals once, because it really can't equal 1, but it can get infinite many close to that. So sub in 1, -2 plus 1 is a -1. So at 1, what did I say? At 1, let's put that back in, -2, -1. All right, and I said that's a whole, okay. And again, this is a line, all right? I'm not very good at drawing it, right? But, oh, did I mess up? I think I did, shoot. Yep, sorry, correction here, 0, 1. All right, when I subbed in 0, we got 1. No wonder it wasn't looking great. All right, we'll fix it. Math is one of those double checking things. So I thought it wasn't looking good because I can't draw very well, but no, I put it in the wrong place. Okay, and notice this one does not go off to infinity, okay? And the reason it doesn't go off to infinity is it's trapped between these numbers. So this is a line segment, has a solid dot there and a hole there. All right, so that's a piecewise function. I'm gonna pause and try to think of like a real life scenario so you can kind of see how you might write one of these. All right. Here's a real life situation where you might have a piecewise function. We'll call it P of X because this is how you're getting paid. All right, what's the scenario here? Well, you have to work 0 to what? You can work up to 40 hours a week. And let me slide that over. I just kind of got a little tight there. All right, so if you work up to 40 hours, you get your normal pay. All right, so let's do 0 to 40. And what do you get paid? And sometimes it's nice to play with the math to see this. If you work 0 hours, your output is 0 money, right? Okay. If you work 10 hours, let's see, and you're making $12 an hour, right? Per hour, you're going to get $120. So your input is how many hours you work. If you work 40 times $12 an hour, your output is what, $480 for your pay. Okay, so if you play with it, you can see that it's kind of always in that format of you have $12 an hour times how many hours you work. All right, so I'm going to come put that over here. All right, but what happens if you work above that? Well, some companies will give you overtime, especially if you're hourly and not salary. All right, so if you're in that situation, what's going to happen? So say you work 50 hours in a week. How does the math look? So it's good to play with the math, all right? And maybe even play with 41 hours, just a tad over. So say we're a tad over, you would get paid the first 40 at 12. And then that extra hour, you're gonna get paid time and a half. So you're gonna get 12 times 1.5. So that's $18 an hour. And then you would add those to get your salary. All right, what about if you're working 50 hours? Well, again, the first 40 hours, you're getting paid $12 an hour, $480. But then you're going to add in what? Well, the excess, you're working 10 additional hours. Time and a half times 12 is $18 an hour. You're going to get $180, and you're going to add those. Okay, so let's say that you're working, an unknown amount of hours, say X hours, but you do know that it's definitely over 40. This is kind of, you're thinking of overtime here. Well, the first 40 hours, you're going to get paid $12 an hour, right? $480. We always got paid $480. That's our base. But then what happened? Well, the excess, okay, so if we go back and look at the math here, how do we get that 1? Well, it's really 41 minus the first 40 hours. Here, it's really the 50 minus the first 40 hours, okay? So over here, what are we going to do? Well, if we work, say, 50 hours, we would take the 50 minus the 40 to get what's left. If we work 41, it'd be 41 minus 40. It's the excess over 40. And then that gets paid, what, $18 an hour. Now, I actually like the format of this better. 480 plus $18 an hour, x minus 40. And then my little requirement over here, I'm going to kind of run it out of space, but x has to be more than 40 hours. Otherwise, that doesn't work, okay? All right, I can kind of squeeze it, I guess, over here a little bit better. That would be off to the side. All right, and so this is an example of real life of a piecewise function. I like this not simplified. If Newton wants it simplified, I guess you have to. Then you'd have to do the distributive property. So you take 480 plus 18x minus, what is that? 32 is that 640? And then combine that, right? Combine these like terms. I like this format better because you can actually see. You can see like, okay, this is what I'm making for my first 40 hours. This is what I'm making for my excess. So I prefer this not simplified, but again, if you have to, because of the computer system, I guess you have to. But this is an example in real life where we use piecewise functions in a real life setting. So, all right, hope this video helps you with some of the weird functions. If you need more videos, let me know. Take care.